Hi to everyone and welcome to this MSA, the Safety Company webinar. My name is Rich and I'm a Senior Manager with IEEE Global Spec, and I'd like to review a few housekeeping items with you before we get started. I'd like to take a moment to familiarize everyone with the operation of the user interface for today's webinar. Now, the large window that you're currently viewing in the upper left, that's going to be the primary window for the webinar. If you look to the right of the main presentation window, you should see the speaker's bio window, and that contains background information on today's presenter. Now, just below that, you'll see a Q&A window, and at any time during this presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will then be placed in a queue for our speaker to address when we get to that Q&A session. Now, if you look to the bottom of your screen, you should see additional buttons that will help enhance your webinar experience. Now, if you'd like to see what a particular button does, just hover your mouse pointer over it, and a tooltip will appear with a description of that button's function. Okay, right now I'd like to introduce today's presenter, Natalie Silva. Natalie's a product line manager at MSA, the safety company. As a global product manager and a product expert, she's responsible for driving innovation through gas detection solutions. Now, after joining the company in 2010, Natalie held various positions, most recently managing product strategy and new product development for gas detection products. Natalie holds a BA in marketing from Mercyhurst University and an MBA from Duquesne University. And with that, I'll pass things over to you, Natalie, to get us started. So go right ahead.
Hello, everyone. Thank you for joining us today as we review refrigerant safety and mechanical equipment rooms. First, I'd like to start by introducing MSA and who we are as a company. MSA was one of the first pioneers in the safety industry over 100 years ago. We are the global leader in gas detection with over 5,000 associates worldwide. I'm located out of our corporate headquarters in Cranberry Township, Pennsylvania. We proudly design and manufacture all of our refrigerant leak detectors here in PA. Through various technologies and product offerings, MSA has been serving the HVAC industry for many years. I will quickly review the outline for today. We'll start with a brief introduction on why MSA serves this market, the industry drivers behind refrigerant leak detection, the standards behind leak detection, and the most common application in which leak detection is used, as well as the technology in which we use leak detection at the earliest level. The topic today is really around refrigerant safety and its importance. There are 3 reasons and why we detect for refrigerants: for safety, for environmental, and for economic reasons. For refrigerant safety, refrigerants have poor warning properties. An uncontrolled refrigerant leak in an enclosed space can result in an IDLH or immediately dangerous to life or health environment. There's also costly implications with loss of refrigerant and heavy regulatory fines. MSA's refrigerant leak detector portfolio covers different applications, and I'm going to go through each of them. The Choguard 5000 is our newest product release, with the ability to see down to 1 ppm to detect a refrigerant leak at the earliest level. The Chillgard LE is for safety compliance, and it can detect a leak at a low level of 20 ppm. And the Choguard VRF is designed to detect a leak within occupied space. As I mentioned before, there are 3 main industry drivers: safety, environmental, and economic. For safety, refrigerant is oxygen depleting and can be deadly in high concentrations. For environmental, it's harmful to the environment and it's considered ozone depleting. And for economic, refrigerant leaks are costly. The first is safety, and it's really our mission that men and women may work in safety, and at the end of the day, they go home to their families. The fact is, refrigerants are toxic and considered an asphyxiant at high concentrations. I'll briefly review how a refrigerant is assigned a safety classification along with some other characteristics. The safety classification for refrigerants is categorized by the toxicity and flammability. Class A is a toxicity level less than 400 ppm, and Class B is a toxicity level greater than 400 ppm. And to classify flammability, there are three classes. Class 1 being that there's really no flammability present, and going to Class 3 being that there's a high flammability characteristic. It's also important to note that refrigerant is heavier than air, and that is a critical item when it comes to application. The second industry driver is economic. The overall theme is reducing operating costs. When you combine the loss of refrigerant plus the recovery process, and then the safety factor with evacuation and safety procedures, it equates to loss in productivity, and that can really add up. The other point is around scarce supply of high GWP refrigerants that are becoming harder to locate. And of course, the newly introduced low GWP refrigerants are higher priced until they've really penetrated the market and are easier to procure. For the economic driver, getting into some real-life costly consequences, in March 2016, Washington Seafood Company agreed to pay almost $500,000 in penalties for violations of the Clean Air Act. In June 2016, Trader Joe's agreed to spend an estimated $2 million over 3 years to reduce coolant leaks, and almost $500,000 in civil penalties. November 2017, U.S. Seafood of Seattle will implement enhanced leak detection practices for leaking R22. They'll pay $135,000 in penalties. So getting into the environmental regulatory requirements. There are a number of regulatory bodies that are driving requirements around unauthorized greenhouse gas emissions. We can only expect this trend to grow exponentially as global warming continues to be a worldwide epidemic. Corporations now include social responsibility as part of their key initiatives in reducing their environmental footprint. And this brings us to current industry standards. The standard that most drives refrigerant leak detection in mechanical rooms is ASHRAE 15, section 8.11.2.1. ASHRAE 15 is a safety standard that is more directive towards personnel safety. And ASHRAE states, a gas detector shall be located in the machinery room in an area where a leak will concentrate. The gas detector must activate an audible and visual alarm inside the machinery room and outside each entrance to the machinery room. The gas detector must activate the mechanical ventilation system, and the activation of the audible and visual alarm and the mechanical ventilation system is to be triggered at the gas value no greater than the corresponding TLV, TWA of the particulate refrigerant. And there's also regulations around environmental safety. And these regulations include CARB, or California Air Resources Board, the EPA, Environmental Protection Agency, Section 608, and the F-gas directive within Europe. Agencies such as the EPA will fine for unauthorized greenhouse gas emissions. Moving into the application portion, we will focus on safety within mechanical rooms. For a mid-sized commercial building, 2 to 3 chillers is common for cooling a space that size. In this diagram, we show 3 chillers, each being monitored for refrigerant leaks. The most cost-effective refrigerant leak monitor is a sample draw system. This is where the central panel pulls in a sample from various lengths, and it's drawn through a sensor. This particular detector can take up to 16 different points back for sampling. The monitor can be mounted inside or outside the mechanical room using flexible tubing like polyurethane or a hard tubing like stainless steel or copper. Since refrigerant is heavier than air, it tends to pull towards the ground. So best practice is to locate sample lines towards the barrel of the chiller on adjacent sides for complete coverage. If there are known areas that have been problematic or have been recently serviced, locating a sample line there is common. As ASHRAE 15 states, each entryway signaling is required in the event of a leak to advise the safety of the environment inside the room. We offer the complete solution of signaling devices and safety equipment such as breathing air respirators, horns, strobes, acknowledge buttons, and pull stations. Really, the best way to prevent a large leak from occurring is through a sensitive leak monitor that has the following capabilities. It should be tied to exhaust ventilation systems, should have the ability to interface with a building management system through digital or analog communication, and it should have the ability to notify facility personnel of a hazardous situation. So now I'm going to move into our newest product offering, the Choguard 5000 Refrigerant Leak Monitor. And I have a brief video highlighting some of the key features.
Your building's mechanical equipment room is the hub of its heating, ventilation, and air conditioning systems. But the equipment in these rooms has the potential to leak harmful toxic gas, including costly and environmentally damaging refrigerant. At high concentrations, these gases can displace oxygen, endangering the people in your building. Don't compromise on safety. The MSA Chillgard 5000 refrigerant monitor can detect a leak at the earliest level of 1 part per million. The Chillgard 5000 helps you keep people safe and your facility in compliance with ASHRAE Standard 15. In the event of a leak, Chillgard 5000 provides a clear visual and audible signal to alert you. The intuitive user interface is easy to navigate and can send you real-time status indicators through BACnet, Modbus, or 420 analog. Work smarter with the refrigerant monitor that will tell you when it's time to service the sensor, pump, and flow systems, track performance, and spend less time on maintenance with onboard diagnostics. When it comes to serviceability, you can replace modules in the field within minutes and calibrate with just the touch of a button. When it comes to safety, you can't afford to compromise. Make sure your monitor is reliable, durable, but most importantly, easy to manage. Learn more about the Chillgard 5000 at msasafety.com/Chillgard5000. Trust the experts. We know what's at stake.
So we launched this product at the beginning of this year to take the place of its predecessor, the Choguard RT. It's been on the market for over 20 years. I will take a moment to highlight some of the key differentiating features of the Chillgard 5000. The first is the user interface. We designed this product with a 7-inch color touch display to provide real-time status. With a dashboard display, safety is always in view. You can easily access the settings, event log, diagnostics, and calibration mode through the user interface. Lower operating costs are always top of mind. We developed a feature called Predictive Maintenance that actually monitors the performance of the pump, sensor, and flow system. The system will send 2 levels of notification. The first gives a warning with troubleshooting techniques. The second alerts a user when a problem with that particular module occurs. So it will notify you if the system needs service. And probably the most important aspect of the monitor is the sensing technology. MSA uses photoacoustic infrared sensing to detect a leak at 1 part per million. The technology uses a highly sensitive microphone that detects only the gas of interest as it is introduced to an infrared light source. I have a brief animation that shows exactly how the technology works. There are other technologies on the market, and they include semiconductor and non-dispersive infrared. I have a chart here comparing the two infrared technologies. So for basic principle in photoacoustic, it measures direct infrared light absorption for a specific gas, whereas non-dispersive actually compares an air sample to inert gas that's stored in the monitor. For zero drift, photoacoustic is known to be inherently stable. So drift is really a non-issue because there's no reference gas comparison that's needed. For non-dispersive infrared, drift can be inevitable due to changes in the environment, like temperature and humidity. That tends to contaminate the reference cell. In terms of sensitivity, photoacoustic has a higher sensitivity for low-level gas detection. That's how we're really able to get down to the 1 part per million. For non-dispersive infrared, detection limits can be well above the TLV for a lot of gases. And really to get to that low level, non-dispersive needs a long sample chamber in order to achieve that. For cost efficiency, photoacoustic really does cut down on maintenance costs because there's no need for a fresh air sampling line. With non-dispersive, it requires repeated auto-zero processing. And this could result in higher maintenance costs due to the frequent replacement of airline filters or scrubbers due to dirt or particulates. And in terms of downtime, photoacoustic is continuously monitoring, so there's really no downtime. For non-dispersive infrared, it requires that re-zeroing process that actually takes the unit offline. So I'm going to go ahead and go through some of the key advantages of photoacoustic infrared. Like we mentioned earlier, it gets down to that low level detection of 1 part per million. It's not affected by temperature and humidity fluctuations, and it's direct reading, not comparative. You have increased uptime because we're not taking the monitor offline for re-zeroing. And you get the longevity because we use very robust components and the overall design of photoacoustic gives you a longer life. Serviceability is another important feature. Our monitor is based off of a modular design that can be easily repaired and upgraded out in the field. Each module works off of its own board that is field serviceable. Some of the physical product features include pre-drilled conduit entries, field expandable valve modules, robust swage lock inlet fittings, and a designated calibration port that makes calibration really easy. Having flexibility in system outputs is critical, whether it feeds back to a building management system or it acts as standalone. The Choguard 5000 ships with native BACnet or Modbus, as well as analog or voltage options. It also comes with 5 8-amp relays that provide 3 levels of alarm. Also provides a fault relay and additional horn relay. The Choguard 5000 is also BTL listed, and that's a BACnet third-party verification. So in closing, we monitor for refrigerant leaks for worker safety, environmental concerns, and economic reasons. The Choguard 5000 refrigerant monitor is a safety solution to mitigate harmful and costly refrigerant leaks. It's sensitive, getting down to 1 part per million, providing you with the earliest level of leak detection. It's reliable where it has advanced diagnostics, and it keeps you compliant with ASHRAE 15. Thank you, everyone. I hope you found this informative and valuable. I appreciate your time. For more information, please visit our website, www.msasafety.com. And now we will open it for questions.
Okay, Natalie, thanks for that great presentation. Now, before we jump right into the Q&A session, I'd like to remind everyone, if we don't get to your question, don't worry. We'll have an answer for you following the webinar. The complete Q&A transcript, including answers we don't have time for, will be sent to all of our registered attendees and will be posted with the webinar when it goes into the on-demand mode. Okay, Natalie, let's get to those questions. It looks like we have a lot of questions that came in. Here's your first one. How many refrigerants can the monitor detect at once?
You can assign up to 6 different refrigerants at a time from the field selectable library.
Okay, thanks for that answer, Natalie. Here's another question. How many refrigerants are in the field selectable library?
There are currently 20 of the most widely used refrigerants, and there's going to be more available with a phase 2 effort.
Okay, Natalie, thanks for that answer. Here's another question. Does the Chillgard 5000 meet the ASHPOD regulation?
Yes, it does. At its heaviest weight of 17 pounds for a 16-point unit, the monitor is still under 20 pounds, therefore making it compliant with the ASHPOD regulation.
Okay, thank you once again, Natalie. Here's another question. What are the default alarm set points?
The first level of alarm is caution at 50 parts per million. The second is a warning at 200 parts per million, and the highest level of alarm is at 500 parts per million.
Okay, great. And this next questioner asks, can I mount the monitor outside?
It is not recommended for outdoor use. We recommend it to be mounted inside the mechanical room or outside the room, and you would run your sample line inside the room.
And thanks once again, Natalie. Here's another question. How many relays does the monitor have?
The Choguard 5000 has a fault, caution, warning, alarm, and external horn relay, making that a total of 5.
Okay, Natalie, thanks for answering that question. Let me remind everybody, if we don't get to your question, we will send them out via email after the webinar. Okay, here's your next question. How many sample points can the monitor detect?
The Choguard 5000 can be configured for up to 16 sample points. The options are 4, 8, and 16 points. You can easily upgrade from 4 points to 8 or 16 just by ordering additional manifold assemblies.
Okay, great. What communication protocols does the monitor have?
The Choguard 5000 ships with native BACnet, Modbus, analog 4 to 20, or 0 to 10 volts.
And what is the measurement range?
The measurement range is 0 to 1,000 parts per million.
Okay, and along those lines, what is the minimum detection range?
The minimum detection range is 1 part per million.
Okay, Natalie, thanks for that answer. We've got time for another question. How often do I need to calibrate?
We recommend an annual calibration, but that's really up to the company's protocol. We offer a feature in the user interface where you could set a calibration reminder to 3, 6, 9, or 12 months.
Okay, Natalie, thanks for that last answer. We're going to have to wrap up this webinar right there. Natalie Silva, thanks so much for sharing your expertise with all of us today. And we'd like to say a special thank you to all of our audience members for being part of this webinar event. Now, we'd like to let you know you'll be receiving an email from us with a link to the on-demand version of this presentation, a PDF of this PowerPoint, an FAQ document, and a Q&A transcript. Again, thanks for taking the time to join us for this webinar event. Take care and have yourselves a great day.